here, October 25th, and we've mostly we've been working on implementing a client-side application using Angular, and recently we moved all the client-side service data. We moved it over to the server where it belongs. Right now we have the client-side Angular JavaScript communicating back to the server, asking for data dynamically, and the server is then responding with JSON data that we then dynamically render on the client side. Okay, and this is pretty much the same technique that that all single-page application frameworks use. Right? We first some JavaScript is downloaded onto some index page or some initial page that gets downloaded, and then that one JavaScript or several JavaScript libraries written by you go back to the server asking for data in some format, typically JSON, to then dynamically render the page. Okay, this is in contrast to the way we classically do that dynamic pages, right? Where all the logic and the rendering happens on the server, right? If you've done any coding using Python or PHP or JSPs, ASPs, all these are server-side technologies, right? That they all execute on the server, right? They access data from either from a database, from the file system, from the network, but on the server. Then they execute templates on the server, rendering dynamic HTML on the server, and then once it gets downloaded to the client, it's all HTML. It's just plain old, just ASCII HTML. Right? That doesn't necessarily have any executables inside. You only get the HTML. Here, it's quite different, right? We have what we get is the template gets downloaded, the JavaScript gets downloaded, right? But no data at first. Right? The JavaScript, having the template, having the JavaScript, it goes back to the server once more for data because it has no data to render, right? It only has templates. Once it gets the data from the server, it then can iterate over that data and render dynamic HTML on the DOM. Make sense? Right? So we've moved the data from the client side Angular over to the server where it belongs. Right? It is the server who should own the data. Okay? Whether the templates should run either on the server or the client, it's debatable. Okay? Historically, it has been on the server, but for the last decade or so, has been moving towards the client, right? Making clients more responsible for rendering the views. So this next couple of weeks, we're going to move the server the data even further into the stack, okay, further down into the back end, right? Right now, it lives in the memory, in the RAM of the server. Okay, so that if the server goes down, all that data is lost. Okay, so as long as the server is going and you add data to the variables on the server, they're still available, right? As long as the server is running, it's being stored in the RAM of the server that is running on a desktop. Yes, obviously there's limitations to that. It's whatever the footprint of the server, how many gigs the server needs or has asked for from the local machine, yes? But at some point it'll run out, and it's not enough. We want something that is more long-term, something that we can store lots and lots of data. So instead of storing it on the server, we're going to move it to the database. Right? We're going to store all this data in the database where it belongs, right? Where it should have been in the first place. Okay. So to do that, we're going to add one more addition to the layer in the stack. Right? We need a database server. Okay. At the beginning of the course, you already set up a database, but we've never really used it. Right? We only tested it to see that the connection is good, that it was working. Now we're going to actually use it for the remainder of the course. We're going to be using the database. We are going to be using MongoDB as the permanent storage solution, and notice that this is a third process running on our infrastructure, right? We have the client is a browser running on one machine, right? Halfway across the world. The server running maybe over here on the East Coast. But the database is also another server, right? Another process, separate process that can again run somewhere else, maybe in Europe. So you have three machines, right? One where the human being is sitting in front of, right, fiddling with their browser, connecting to a server that is running, somewhere else in some other geographical location, and the data perhaps living in a completely different geographical location. So there's going to be lots of HTTP networking communication between these three, right? The client generating HTTP requests for the server, and then the server fetching data from the database, right, and some other server. In our case, it's being hosted on MLab, right? Heroku is being hosted on the Heroku servers, whereas the MongoDB is going to be hosted on the MLab servers, right? So completely two different companies, right? Two different vendors, talking to one another. So this introduces additional challenges, more or less the same challenges that we had when we moved over the data from the client to the server. Right? We had to adapt and refactor our code so that it no longer the access to the data was no longer a synchronous call, right? Because the data no longer lived in the same process, right? When we moved it over to the server, now we had a network connection there, right? There was risk of latency, risk of taking too long, and the response never resolving. Yes, so we introduced asynchronous communication, correct? Where the client sent over an HTTP request to the server, and then but never waited for the server to come back, right? It registered a callback, right? It subscribed to a callback saying, hey, when the data comes back, give it to me, right? Interrupt me. Well, we're gonna have the same exact challenge when we move the data to the database server, right? Now we're gonna have the Node.js server asking for data from another server, right? That's gonna be hosting the MongoDB. So again, we're gonna have to use asynchronous calls, right? To handle the latency, the risk of latency between the Node.js server and the database server. Make sense? Okay. If we had the database server and the Node.js server, perhaps we could get away with not necessarily opening up a network connection, right? That we could do in-memory, communication between the two processes running on the same machine. Okay, but that is not usually the case. The case is that you have a dedicated Node.js server and a dedicated database server. Okay, that's a more common setup. Right, so that's why we're going to introduce this this new tier. All right. Okay. Let's do it.